So I see the light?
Oh, you see the light?
Thank you, Ms. Jenkins. All right, so sorry for the major delay. The next one we're going to look at here, we have a geometry problem for the second one. So first, again, you get probability of appends is 3x to the 4x or 3/4 there. Okay? Can somebody, Andrew, can you hit lights in the back? Thank you, sir. Yeah. Buddy, can you turn the blind behind you? All right. Let's take a look at the second one now. The second one's a good problem. It makes you think before you can actually do the probability for this problem. So, the problem starts by telling us, in the figure below, ABCD is a square, which is one of the key factors here. And it tells us it has an area of 576. If you know the area of a square, what do you also know about the square? The length of the sides. If the area is 576, what's the length of each side? Why 24? Square root of it. Let's take a look. It tells us that the area of this square is 576, which means it must be 24 by 24. So you can start by labeling this as 24 here and labeling this as 24 here. Okay, that's our first key point we notice. Next, it then says line segment AE, right here, this little piece vertically, is 1/4 of AD. 1/4 of AD. If AD, again, is 24, what would AE be? Be careful, 6. It's a fourth. It's a fourth. You're going to have 6 right there. Again, AE is 1/4 of the full height. The full height. The full height is 24. 1/4 of 24 is our 6.
I'll have to look at it as well.
Okay, thank you. It is working though now. Thank you very much. Then it says that ABGE, if we look at ABGE, that's this little part with like 3 bricks up top. ABGE, right here, is divided into 3 equal rectangles. Therefore, each of their lengths are what?
8.
8. Very good. Because 8, 8, and 8 makes 24, which is the width of the square. Next, line segment FD, FD is this little piece down here, is 1/2 of ED. See ED right here I'm pointing to? From E to D. So this, what's left over here, we can see is going to be, it's 18. Take a look. This is 6, right? This is 6 right here. So what's left over by segment addition postulate is 18. If it's 18, then this must be 9 and 9. And that's not a 16. That's me just drawing a line next to it. So we're not confused. So again, we've got 6, 9, 9. Why is this 9 and 9? Because it says that line segment FD is 1/2 of ED. And ED, what was left was 18. 1/2 of 18 gives us the 9 there. And EGCD is divided into 4 equal rectangles. So what must these be? Good. 12, 12, 12, and 12. So we've pretty much labeled the whole thing at this point. Everything is labeled. I mean, even these are all labeled. You can put 6s on them. You could put a 9 on this one and this one right here. Because by default, right, translation properties. So we've got, if a point is randomly selected, what is the probability that the point will be in a shaded region? So what was the hard part about this problem? Because the next part is not going to be that tough. Yeah, finding, you know, all the dimensions and all the labels and stuff. Want to help me with the part now for the probability? What's the area of the shaded region going to be here then? Shaded.
First I guess the shades would be left for the bottom square.
Good.
Same for the other shades.
Well done. So the one up top is 6 by 8, which gives it an area of 48 plus, what's the other shaded area? 9 times 12. What does that give me? 108. Very good. All over 576. Why do I not have to do any math? You're given. Aren't you given 576 in the beginning? So please don't find all these areas and add them up. That's a waste of your time, right? I'm just giving you a little shortcut here. Again, the whole thing was given as 576. So there is no need to do all that work. So technically, once you got the dimensions of this rectangle and this one, couldn't you have stopped?
Yeah.
Because you knew all you needed was the shaded part. So when you read through these problems, feel free to read ahead and take a look. So that's your probability. you're going to end up getting 116 or 156, right, out of 576. Any reduction there? 13 over 48. Others agree? Is that right? 13 over 48. Just, you remember how to do this, everybody? Go in your calculator quickly. Press 156 divided by 576. Hit enter. Then press math, enter, enter. It'll convert it to a fraction in those terms. Again, do 156 out of 576 in your calculator. Simply hit enter. Then press math, enter, enter. It'll convert from a decimal to a fraction. And it is 13 out of 48. Okay? That always works. Whenever you want to reduce something to lowest terms, you can use your calculator for it. Okay? If it helps you for speed. I would not want to reduce that to lowest terms, but in my head. It makes it easier to do it with the calculator there. Questions on this one? Again, the theory here is this. When you want the probability of a shaded location, you take the area that's shaded over the total. If you wanted the unshaded, you take the unshaded area over the total. Now, think back to real theoretical questions. If you know the shaded area, you technically, probability, you know the unshaded probability. Because what do they always add up to in probabilities? Yeah, go back and study. What is it, Jay? Or whoever just said that? It is 1. Danny? Sorry. Thank you. So Jason's math, but I heard 1. So, again, the probability, I was giving you credit for a right answer. The probability of events happening is always going to be a sum of 1. Just like if you think about the dice, right? What's the probability of each side landing on a dice? 1 out of 6, right? And if you have 6 sides, 1 out of 6, and having 6 of those, you sum them up, you get 6 out of 6, or back to 1. The probability of an overall event, of any event happening, and of all the possibilities, is always going to be 1. Always, always, always. So, if this is 13 out of 48, the probability of landing in an unshaded region would automatically be 35 out of 48. This is unshaded. Not that it asked for it, but just as a note to write down. This was shaded. Unshaded was 35 out of 48 because these have to add up to 1, or 48 out of 48. Again, the total probability of any event happening is always 1. You really want to write that one down. Can't emphasize that enough. Okay, again, because these two events add up to 1, you think of it as 48 out of 48. So the numerators would clearly add up to 48. And just look at your numerators there. You can also do this with a decimal in the calculator. You can always find the decimal value and then find the complement of that, or see what adds up to 1. All right, let's go on. All right, let's take a look at number 62. 62. Determine the probability of choosing a king followed by a queen. I should put out of a standard deck of cards. Sorry, it was late. Out of a standard deck of cards. King followed by a queen. Probability of a king.
2 out of 1 out of 4.
I don't play cards.
That's all right. And means.
4 out of 51.
Question is, and means.
Times.
What is it? Times. Thank you. Then others that answered a second ago. For the queen, how many are left? 4 out of how many cards now? 51. Because once you pick that king right, how many are left in the deck? Okay? If the problem said, you have to make sure you notice this, guys. If the problem said with replacement, then you take the king that you pulled out, and what do you do with it?
Put it back.
Put it back in. So the second part would have been 4 to 52 still. But it does not say with replacement. So if it says followed by, it means that you take the king out, or whatever the first card is, and now there's 51 left, and then you draw the second card. Okay, then you draw the second card. Ashley.
What if it says, and queen, wouldn't it be like replacement? Wouldn't you put the card back?
If it said what?
Like, for example, if it was like king and queen, wouldn't you
Of drawing a king and a queen?
Yeah.
At the same time or separate times? That's the,
Every time.
this is separate times here.
Oh, what
This
about,
is
what about the same time? Wouldn't it be like 8 out of 5?
you would have to do. Remember what we did with the dice, where you can get one number or the other? You would have the probability of getting 4 to 52 times 4 to 51. Getting this would be right. King, then queen. Isn't that what this is here? But if it didn't specify followed by, if it just said getting a king and a queen, you can get a king and a queen, or you can get a queen and a king. So you'd have to do, again, this is if it did not say followed by, you'd have to do plus 4 to 52 times 4 to 51 again, because this represents the probability of a queen and a king. So this would be your answer if it did not say followed by. Absolutely. It's a good question to ask there. Again, if order does not matter, if it doesn't say followed by, now we're saying we can get a king and a queen, or a queen and a king. And or means plus in math. Or means plus there. Okay, keep that in mind. Good question. Keep that in mind, actually, for the next one. Okay, I'm not going to do the next one with you right now, but just keep that in mind for the next one. Let's go to 63. Yes, Jason. Okay. Let's do the bottom one. I'm going to leave the top one for you to do yourself. So let's go to this one right here. In how many ways? Thanks, Sean. So, for this problem, it says, in how many ways can 9 different books be arranged on a shelf? So that 3 of the books are always together. So that 3 of the books are always together.
So that means combination, order matters, right?
So order kind of matters here, right? Order kind of matters. So we're looking at a permutation. But this one is much more complicated than a basic permutation. So let's take a look at a sample. Draw 9 slots, please. Draw 9 slots. Okay, or places on the bookshelf. 9 of them. Okay, we got 9 slots. Now, if this problem told us, again, it was just 9 books being ordered, it would be 9 choices, 8 choices, 7, 6, 5, 4, 3, 2, 1. Agreed? Okay. Now, this problem we have to think about the fact that it specifies that 3 of the books must be lumped together, right? 3 of them must be lumped together. So, if 3 of them have to be lumped together, I have to think about this as a segmented permutation, like a piecewise function. Think back, we talked about this quickly at some point this year when we did domain and range, where we had a function that might have looked something like this, right? And it was in 3 different pieces. That's a linear, this is a quadratic, and then another linear. That's what you need to think about here. Yes, exactly, like the airplane one, that's exactly right. Where the family has to sit together, right? That's how they do these things. You have to think about it that way. Certain things need to group. Or the one with the baseball team, and you have 9 players, but the pitcher must bat last. Remember that? Only some people got that on their quiz. The pitcher had to be in the 9th spot, and then we had 8, 7, 6, 5, 4, 3, 2, 1, and then only 1 choice because it had the pitcher. So, you have 3 people in this group, right? And how many over here are books? 6. 3 here, 6 over here. So, you have how many choices right here?
3.
How many here?
2.
How many here?
1.
But then over here, what happens? What do you have now?
1.
6.
5. 4. 3. 2.
Now, this is pretty much saying the answer is 3 factorial, 6 factorial. Isn't that what that is, really? Because this is 3, 2, 1, or 3 factorial, 6, 5, 4, 3, 2, 1, or 6 factorial. Therefore, the product of 3 factorial and 6 factorial is your answer, which is different from something like 9 factorial. If that grouping did not matter, this would have just been 9, 8, 7, 6, 5, 4, 3, 2, 1. These are all the same over here, right? But notice the difference on this side? Your answer will be much less than if it had not specified that grouping of 3. So whatever you get here, okay, whatever you get for this answer right here would have been different had it been the one with the red ink up top, which would have just been 9 factorial, if the grouping didn't matter. But since the grouping does matter, we are looking at this answer right here. Okay? Again, if the grouping didn't matter, it would just be 9 through 1. So 9 factorial. But since the grouping does matter here, though, since it does matter, it must be those 3 together and then those 6 together. I heard like a half question there. Vanessa? You started a question, but you didn't finish it. No? Okay. Factorial. How do we do it? Press Math, good, and then go over to probability, and then look at the exclamation. And again, you don't, as Luis showed us, you don't need a time symbol or parentheses. So you can simply type that exact code in. 3 exclamation, 6 exclamation. It automatically knows to multiply, and you do not need parentheses around it. Okay? If you're dividing something, then you have to consider parentheses around your denominator. Okay? If this was a free response, you could leave it like that. I have no problem with that at all. Okay? Because it is the right answer. But I'll tell you now, it's probably not going to be free response. It's probably multiple choice. Okay? Because it's not that tough of a problem. So I wouldn't make this a free response. All right. And if it's a multiple choice, obviously you might have it like this. I might make a multiple choice like this. I might leave it like that with those numbers, or I might put the actual number down. What does the number turn out to be for this?
4,820.
4320? And somebody real quickly, type in 9 factorial. Somebody tell me what 9 factorial?
362,800.
Look at the difference. Okay, because that grouping, look at how many possible choices we have now. Or how many different arrangements or less. We went from 360,000 to 4,000 just from a grouping of 3. So think about the headaches that airlines go through when you tell them you want to be grouped together. Right? When you want to be grouped together, they have much fewer choices to make. That's why they write algorithms and they write computer codes that do this for you. They don't actually sit there and put you in groups and say, oh, let's do this, get in. No. Half the time you pick your seats, okay? Or if you buy 4 seats together on a big airline and there's groups of 5, they'll give you 4 together. The computer program will do it for you. Okay, you're not going to actually have a person doing that. All right, I'm going to leave the first one here to yourself, to do yourself, because, actually, let me start it off, and then I'll leave you the rest. It says, in 7 days, Mario cooked 98 pounds of spaghetti.
It's me.
Love my spaghetti. Yes, to me, Mario. Yeah, I didn't know if anybody picked up on that. It's Mario and Luigi. Okay. Each day after the first, he cooked 2 more than the previous. Right? So he started with some amount, and the next day he cooked 2 pounds more, and then 2 pounds more, and then 2 pounds more. So, John, what can I call the first day? Just X. I don't know if that was John, but I heard it. If he cooks X on the first day, John, on the second day, how many does he cook? Focus, come on. I wasn't trying to call you out, but I need to know. Just focus. Here, X plus 2. What about the day after that? 4, because he's adding how many pounds each day? 2 pounds, right? He's adding 2 pounds. Hopefully, I don't add 2 pounds every day. Okay, but he's adding 2 pounds of spaghetti here. So we got X plus 4 now. How many days does it go on for? 7 days, okay? 7 days. So we got X plus 6, we got X plus 8, we got X plus 10, and X plus 12. We're all clear on that? Okay. Now, that is the amount of pasta he cooks each day. It says, altogether he cooks how much pasta? So let's sum those up. I see that there are 7 X's, and if I add all the numerical values up, I'm going to get, it looks like 32. Right? I get 6 here, and another, so this is 6, and 6 is 12, and 20, and 42, and 42. Good thing I checked. Okay? So that's what we're at right now. Why did I set that equal to 98? Because that's the total number. He cooked 98 pounds of pasta, and these are my 7 days. I add up my 7 days, I get this value. I set that equal to 98. It says next, what is the difference between the average and the median? The average and the median. What do I do to find out the average and the median? It would help to solve for X, absolutely. It would help to solve for X. So, solving for X, what do you get here? 8? Okay, if X is 8, where's the median in my set of data? In the middle. Isn't this the middle of all my data? There's 3 below, and then there's 3 above if they're in order. Again, smallest all the way to biggest. So what's 8 plus 6? So the median is 14, right? That's the median. What do you get for the average? It's 98 divided by 7. Right? The total is 98. He cooked 98 pounds of pasta over 7 days. What's 98 divided by 7? It's 14. So the average is 14. That's why I wanted to do this in the end, because I remember this problem. The average is 14, and the median is 14. So they are what? So is there any difference between them?
No.
So what's the difference? 0. Again, when data is consecutive, the median and mean are always the same. Again, write it down, please. When data is consecutive or has consecutive intervals, the mean and the median are always identical. Think about 1, 2, 3, 4, 5. The average is 3, and the median is 3. It's always the same. So when data has consecutive intervals, or evenly spaced, if it helps you for better wording, evenly spaced intervals, the median and the mean are identical. Okay, again, take a look at your spacing. What was the spacing between each data? 2, up 2, up 2, up 2, up 2, up 2. When the spacing is even, or when the data is spaced evenly, the median and the mean will always be identical. Okay? The median and the mean will always be identical. I'm going to leave you the next one to do. It's going to take some thought. Let's jump to 65, and we're not going to do identify the 4 sections. You can do that on your own. Let's go to determine this one here.
What number is that?
The 4 sections of a conic section? What are the 4 sections, quickly? Circle, ellipse, parabola, hyperbola. You're not here, you got to watch that video, guys. Circle, ellipse, parabola, hyperbola. Good. I did. I returned everything that I took. Determine the section from the given equation above. What do we use here?
4AC.
Good. B squared minus 4AC. So take a look here. This is what I'm going to give you tomorrow on the test. Whoops. Come on. This is what you will be given tomorrow on the test, right here. You'll be given the sum of cubes formula and difference of cubes. Remember how this works. If there's a plus here, if you're doing sum of cubes, you use the upper of them. Use the upper. Okay, that's what the 3 you would use there. If it was difference of cubes, and it says a minus here, this would be a minus, and this would be a plus over here, and this is still a plus no matter what. That's that one. Up top. Up top. How do you know the difference between a circle and ellipse?
Isn't B equals 0?
Good. For a circle, you have 2 things happening here. B is equal to 0, and A must equal C. So if you get a negative discriminant, it can either be an ellipse or a circle. If it's a negative discriminant, and B happen to be 0 and A happen to be equal to C, then it's a circle. Okay, so that's how we use that table. So let's go ahead and look at this now. Let's go ahead and look at this. What does it have to be in the correct order? Order. So we start with x squared in the front. Then we go to the xy term. Then I need a y squared, but I don't see a y squared on the left-hand side.
You have to move it over.
Good. So what do I move it over as?
Plus 2.
Good. So move it over as a positive 2y squared. It doesn't matter where I put it over here, as long as I put this in order. Now, does anything else matter?
No.
It doesn't. When you're only determining which section it is, nothing else matters there. Nothing else matters. Because A, B, and C are all that matters. It's B squared minus 4AC. So, simply now calculate B squared minus 4AC. Here's B, here's A, here's C. We get negative 6 in parentheses, which many of you seem to be forgetting on your quizzes, because a negative squared must be what?
Positive.
A positive. And if you forget those parentheses, some of you are typing it in and getting a negative there. That's not logical. You need to think about logic and not just your calculator. Minus 4AC. What's 4 times 3?
12.
What's 12 times 2? So it's minus 24, right?
Yeah.
So is this number going to be positive, negative, or 0?
Positive.
Doesn't matter what the number really is.
No.
Good. All that matters is that it's positive. And when the discriminant is positive, we have what shape?
Circle. No, hyperbola.
There it is, hyperbola. Look at your data table, please. Okay? Look at your table. When it's positive, whoa. When it's positive, we have an hyperbola. Okay, we have the hyperbola. All right. Almost there, almost there. This problem, there's no center on here. So if you would like to help you to draw the center,
It's on 2.
is on there? Perfect, never mind. Should be at 2, -1, I think.
Yeah.
Okay, 2, -1, that's the center. Now, if the center is at 2, -1, what do I know about this problem? What must it look like right away?
We said what it must look like right away.
If it's at 2, 1, what can I do about the HK parts?
You know that that y must be
One person, guys.
y must be plus 1 in the equation.
Good. Why has to have a +1? Because there's a -1. And what about x?
It has to be x minus 2.
So this is your answer by default, isn't it? Again, this tells us we do the opposite. Remember the standard form is this right here. That's our standard form right there. So if it's 2 as the center for x, then it's got to be x minus 2 squared. If it's -1 as the center for y, then it's y plus 1 squared. The only answer with that is choice C. And take a look at the radius. The radius is 6 here. How do I know that? Well, I can't judge that, right? So I just go horizontally. I go from 2 to 8. There's the radius, right? That's the radius here. That's what I'm doing. So what's 2 to 8? Isn't that 6? So you have to see a 36 here. Very good. Because it's always radius squared at the end. Okay, we're going to run out of time in about a minute. Here's what I want you to do tonight, besides the problems we didn't do. First, put this in standard form by completing the square. Look at your notes if you need help on that. Remember, you got to move the constant over first. Move that over, and then do half of b and square it, half of b and square it. Go through that process. Finally, down here, we're going to have to factor. Well, quickly, what's the first one an example of? Good, dots. First one's dots. Second one, what are you going to use? Or grouping, we're going to call it, because it's not AC anymore, but grouping. It's like AC, where we're going to split it. Very good.
The bottom part.
And finally, the last one, what is this going to be an example of? Cubes. So, if you want to think of these as cubes, oh, I forgot it's Monday. We have 2 minutes. We'll do the bottom one. If you want to do this as cubes, here's what I think of. A cubed plus B cubed, right? So, this is tough because of the fraction people see. But aren't these all cubes?
Yeah.
What's the cube root of 27?
3.
Cube root of 8?
2.
64?
4.
4. So we end up getting here. I think of A as this. Think of this as 3 over 2 x squared plus 4, cubed plus 4 cubed. Think of this problem like that now. And think about it. It makes sense. If you cube 3, what do you get? Back to 27. If you cube the 2, you get back to 8. If you cube the 4, you get back to 64. So what this tells me is that this is A, and this is B now. That's what helps me. If you can identify A and B, then all you have to do is plug it into the formula. And the formula tells me this. Oops. The formula tells me A plus B, A squared minus BA or AB, does not matter, commutative law, plus B squared, which is not to confuse. Okay? So I go ahead and I plug in. This is going to be 3/2 x plus 4. This is going to be 9/4 x squared minus 12/2 x plus 16. Let me just write this in steps because I'm skipping steps and I feel like that might confuse people. So this should be 3/2 x squared when I plug in. So again, what am I doing? I'm taking this A right here that I've identified as A and I'm plugging it up here, over here, and over there. I'm taking the B value, which is 4, and I'm plugging it in here, here, and here. This is what I end up getting. And just simplify. Okay, this becomes 9/4 x squared. This becomes a 6x. Okay? Again, tonight, please make sure you're studying. Tomorrow's your last day for makeups on 61 through 67. So if you plan on making up anything tomorrow, that homework must be in beforehand.